Anything, guys? You guys doing all right? I'm gonna ask that a lot, so I apologize because I can only see 4 people, so I'm gonna reach out every now and again to my little black boxes. Let me see here. All right. So if you guys don't have any questions, we're just going to jump right back in. Let's see. Let me turn off Toby. There we go. Let me think. Was there anything else I wanted to tell you guys? Oh yeah, what's happening today in the country? Anybody know? You're all like, dude, that's a little vague. There's a lot happening today, Jeff. But anybody know what the big thing's happening?
Georgia?
Georgia, the Georgia runoff. Yeah, I was born in Savannah, but I can't vote in Georgia anymore. So damn. So yeah, we're probably not going to know the results tonight. It's probably going to be very similar to the November 3rd election when all the states said, man, we should probably count all these votes that were mailed in. Anyway, that's enough. Sorry. So let's get back into where we left off. Let's see, where am I? Get out of there. So we made it through, we got in most of 1B done. So let me kind of go back over. You can see behind me on the board the last stuff that we did. All right, here we go. Hold on. Okay, so far we've done, we talked about logical connectors. We talked about something like P and Q, right? And this is only true, do it, Jeff. Only true if both are true. This is an excellent little phrase to remember. So when you create a truth diagram, a truth table, you can very quickly fill it in just by looking for when they're both true and then everything else is false. Anybody remember what the little phrase is for Q? Por qué? No, por P or Q. It's only what if both are what? Anybody remember?
Nobody. Only true if both are true?
No. That's and. And is very uptight. And is like, real quick, let me tell you this little story. You ready? Have any of you ever went to a bar or somewhere that had a person at the front and you're in line waiting and they let certain people in? Anybody ever went to one of these swanky places? No. So, but you've all seen it in movies and stuff, right? If you've never done this before. And let's say you're in the line and the guy comes to you, you're not on the list, and he's like, all right, to get in the bar, you have to know Joe, the bartender. I know Joe. And you have to have a lot of money. I'm a teacher. And you have to dress. I'm like, you can stop right now. So and is very uptight. I call it the mean bouncer. Right? Or very relaxed. I come up to the org bouncer and he says, all right, to get in the bar, you have to have a lot of money. Shit. Or, yeah, you have to dress nice. Shit. Or, yeah, you have to know Joe. I know Joe. I go in. So and is very restrictive. It can only be true if they're both true. Or is very relaxed. It's only false if everything is false. Right? So only false if both are false. I like it. So what does that look like in a truth table? Take a minute. Can you write down the 4 things here in the right order? See if you can create this table for me real quick. Shit. Got too much stuff on this table. All right. So it's always starts with true, 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 false, then false, true, false, false. Now, it could have been any order. Today, we're going to see why the order is important. It has to be in that order so I can compare it to other statements. And then so P and Q would be true if they're both true. So that's the only T. Everything else is F. Become an F. And then P or Q, let me see if I can do this. I'm going to add one more column on there. We did this yesterday. It's all in the video, but I just want to kind of bring this back up. It's only false if they're both false. So that's the only place that's false. Everything else is true. So if I said, I'm a math teacher and I wrestle alligators. Sorry. Yeah, I'm a math teacher and I wrestle alligators. That's false. I'm a math teacher or I wrestle alligators. That's true. Does that make sense? Yeah. Okay. All right. I like it. Some of you guys are like, well, yeah, thanks, man. I've learned so much already. Oh, be quiet. All right. So here's another one that we haven't talked about yet. It's called the conditional. If P, then Q. And this is the one that is so evil. It is the easiest one to use inappropriately to make people believe certain things. And there's a lot to it that's really on the surface doesn't make sense. So first off, what does this look like in symbols? It looks like this. And those symbols make sense. P happening leads to Q happening. So if I said something like, if you make an A, then I will buy you a car. You can do it, Jeff. Right? If you make an A, then I will buy you a car. Okay, and some of you guys are going to be like, look, I made an A, and look, it's on the video. He said he would do this. And I'm like, here's your Mattel car. Good job. Now, does that mean, so let's say you make a B. All right, let's say you make a B. Can you tell me anything that comes from that? Can you say anything definitive? Does that make sense? If you make an A, then I'll buy you a car. You make a B. Can you say therefore anything?
You don't get the car.
Uh-oh. That's not quite right.
You almost get the car?
No.
Anything?
Huh?
You don't get anything because nothing was said of what you would get if you got a B instead of an A.
Your reasoning is correct, but your conclusion is wrong. If you don't make an A, I can do any freaking thing I want to. I can get you a car. I can get you 18 cars. I really want this to make sense. The only time that something has to happen is if you make an A. You guys agree with me? If you make an A, I'm going to get your car, right? If you don't make an A, is there anything that says I'm not allowed to get you a car? Could I get you a car if I still wanted to?
Yeah.
Yeah, and it would still be a true statement that was made. Let me make one a little more immediate here. Let's see. Oh boy. All right. First thing's coming to my mind is a little gruesome, but too bad. If anybody ever watched that movie Highlander? No. All right.
A little bit of it.
A little bit. Okay. It's not a prerequisite for the course. If if your this is so evil, but too bad. If your head is cut off, then you die. Everybody agree? Yeah, it's pretty much, I mean, yeah. You could argue, well, Jeff, that's a fallacy just because we haven't seen it happen yet. Be quiet. So if your head is not cut off, if you don't make an A, if your head is not cut off, will you live forever?
Maybe.
I love you guys so much. All right. Understanding that men definitely die, that people die, humans die, every animal dies. Oh, you can kind of argue about certain jellyfish. Are there other ways to die? Basically, is really the point here. Yes. So this is not an exhaustive list of ways to get here. If you do make an A, I will buy you a car. If you don't make an A, I can do whatever I want to. I could still buy you a car. If your head is cut off, you will die. If your head's not cut off, you could still die. Of course, right? We're not, anyway, so that's what, like the Highlander things, the only way they can die is to cut their head off and blah, blah, blah. Anyway, A is false, so B is false. Oh, no. I'm not sure what you mean. Are you calling this A and this B? So if you make an A, if that's true, then so let's really break this down. Stay with me. If you make an A, if that's true, the only way the whole statement can be true is what? If it's true you make an A, what must this be to make the whole statement true?
Buy the car.
Yeah, both of them have to be true, right? If the first part's true, the next part has to be true, or else I was lying, right? Or else this is a false statement. I really want you guys with me. If the first statement is false, then the next statement could be true or false, and the whole thing is good still. This is like a contract that says, if I finish the job, then you'll pay me. If I don't finish the job, then you're not restricted to anything. You could do whatever the shit you want to in that case, right? I really want this to make sense. So let's look at this from a truth table standpoint. Let's create a truth table for the conditional. So if P, then Q, which is if P, then Q. So we got there true, 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 false, false, true, false, false. So what's the first thing? If you do make an A and I do buy you a car, so if P is true and Q is true, is the whole statement true? Did I uphold the contract? Yes, so the whole thing is true.
Yes.
If you make an A and I don't buy you a car, did I uphold the contract? Is the whole thing true? Hell no. Now, here's the interesting part. If the first part's not upheld, then I'm released from any conditions. I could do whatever I want to. So it doesn't matter what the shit the next thing is, right? Have you ever heard somebody go, uh-oh, is my Wi-Fi okay? Oh. Have you ever heard somebody say, oh, really? If you could do that, then you know, pigs fly and blah, 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 right? That's a horrible example. But if something is, if the first piece is false, the next piece can be whatever the hell it wants to be. These are both true. This is the only time, and I like to look at it as a contract. If you do this, then I will do this. The only time the contract was broken is here. That's why that's the only time it was false. I'm sorry, Nikki. I'm not sure where that. I don't keep up well with the chat. I'm sorry. Okay. So what's the little statement we can make for conditionals? If P then Q is false, you can do it, Jeff. If true implies false. That's the only time it's false. I like it. Hey, Mikey. All right, so let me keep this up here. Oh, you guys all right? What's up?
Can you just repeat that right there? What you said when you wrote that?
The conditional, if P then Q is only false, let me put only, is only false if true implies false. Do you see what I mean? True implies false.
Okay, thank you.
You're welcome. And I really hope that makes sense. People get really confused about these. But that's the way to look at it. If the first part is false, I'm allowed to do whatever the hell I want to. I could do it or not. And it's a true thing that I said. Because you didn't hold up your end of the bargain. So I could do whatever I want to. Nah. So what I want you to do, let's see who remembers how to do this from yesterday. I know it's 24 hours ago, but let's see. Can you create a truth table for not Q implies not P? Oh, shit. I'm not going to say a word. Try to do it. This is not graded, so you can do whatever. Excuse me. Excuse me. I would highly recommend you do this. Do you see how I can just kind of, I've already got my P's and Q's defined. So then I can just make a not Q and a not P. Your inputs always must be in this order, and we're about to see why. Just to make sure everybody's on the right track. Dadgummit. Sorry, somebody was calling me. I forgot to put airplane mode on. What am I trying to say? Oh, not Q. What goes here? What goes under not Q?
I'm lost now.
All right, let me start over from scratch.
Yeah,
So
because
true.
I'm confused with the left half of the board and the right half. So
Gotcha.
are we just working
They were
with the
actually,
right half of the board?
so here, let me start over from scratch.
Okay.
So you
Thank you.
define your P and your Q. All I was doing was saying I've already got P and Q here. So let me just keep going. But you don't have to do that. Here's my P, my normal P and Q, how it's set up always, right? Now, what do I have to build before I can analyze this? I've got to build a not Q and a not P.
There we go. Okay.
Everybody with me? Yeah. So all I was trying to do was say, why would I rewrite this when I've already got it right there?
I hear you. Okay.
But you can start over from scratch. That's fine too. So what goes under not Q? If Q is true, not Q is
False.
false. It's great. So it's just going to take each of these and invert them, right? What about not P? What goes here?
False.
Is everybody, are you guys, anybody not with me? Let me ask it like that. I really want you, does everybody understand that when I write something here, I go row by row? So this is not P. In this row, P is true, so not P is false. P is true, so not P is false. P is false, not P is true. P is false, not P is true. And now I can analyze this because I've got all the players. I've got all the players created. Why was this one so easy? Because the players are P and Q. They're already there. Why is this one more difficult? Because the players aren't what I start with. Damn it. So I got to make them and then I can do it. So it's only false when it's TF. So what's the only row that's going to have a false here?
The second row.
Second row. All the other ones are going to be true, true, true. These are true because I could do whatever I want to after you didn't do this first part. And this is true because it was upheld. You did it and I did it. So it was upheld. Okay. I love you guys. I have no idea what's in your head right now. If you hate this, if you're like, what the shit? This is the real nitty gritty of how to analyze an argument.
Well, you know, I'm getting it. It's just that it takes me longer because it's new to me. So
Yeah.
I have like it's your daily bread. For me, I can get it once I go to my notes and I look through the book. And if I were to review it like 3 times, I would get it like quick, you know?
Yeah.
So yeah, I'm not totally lost. Just I
Good.
just got
Good.
lost, you know, with the left side of the board. But yeah, I get it. I don't know about everybody else. I don't know if
No,
I'm
I'm
the
just
only
saying-
person who doesn't get it because I don't hear anybody else not getting it.
Well,
That's-
I just have a question. Like, so would the problem be just like the squiggly line Q? Like, would that just be the problem on the right-hand side of the board there?
How do you mean?
Like-
I'm sorry. So the answer would be this.
No, I know, but like, so like, would the problem just be like presented just to like how it's written above? Like, that's what I'm trying to, because this is all like she said, this is all new to me too. Like, I
Gotcha,
didn't.
gotcha. So this would be the question they asked. They would say, make a truth table for this.
Okay, and you said the PQ, so we're gonna use that same PQ for every single truth table we do. Okay, yeah.
And we did one yesterday where I gave you one more letter, remember? So
Yeah.
they like, we use, just like in algebra, we use X, Y, and maybe some of you guys have used Z also. Right?
Oh, I see
In
what you're
logic,
saying.
we use P, Q, R, S. And then, of
Yeah,
course,
I didn't know
54.
what you meant by that.
Yeah.
Oh,
I like,
wow.
that's my favorite sound.
Okay, I
yes.
just thought of a question. So we're working with the base is PQ, and then the question is not Q, not P, right?
Yes.
Now, how did we just get the 5th column? That the last part, the answer. How did we
I'm
figure
with
that
you.
out?
I'm with you. How did we get this?
No. The
No,
one
no,
over there.
I know. How did we get this? By comparing
PQ.
these, right?
Yeah.
Because those were the parts that I needed. How do I get this? By comparing this and this the same way.
I get it. Okay,
I like it. I like
got
it.
it. Thank
And
you.
that is why I did not Q and then not P, because then it's easier to see. Now I want to point out something. What was the answer to this? This is a really strange question, but I basically just gave it away over there. Sorry?
That entire table is the answer
This
to that question.
entire, right here, this column, that's the answer. Why is there no specific answer? Because it's just like a function, right? How many answers are there to y equals 4x plus 7? Infinite. Real quick, stay with me. You guys remember that? Right? Because how many numbers can you put in place of x for y equals 4x plus 7? How many numbers can you use for x?
Any number.
Huh? Sorry?
Any number.
Any number. So an infinite number of numbers. Holy shit. Which is why we graph the answer. Because I can't list all the answers, but I can graph the answers and just say, follow the line. Here, how many inputs are there total? 4. Thank the gods. So the answer doesn't need to be a graph. I really want you guys to see the connection with algebra here. The answer doesn't have to be a graph, thankfully, because that would be weird to graph T and F. The answer is just all the possible outputs. And that's why these have to be in this order, because now can I compare these two? Are these two statements logically equivalent? I'm not even going to explain what that means. What's your gut tell you? Are these two statements, looking at their answers, are they logically equivalent? Yeah. Because their answers are the same. Why does that make sense? If you make an A, then I'll buy you a car. If I don't buy you a car, then you must not have made an A. I was waiting for somebody to finish it up, but you guys, you're all like, he's just on the fritz. I don't know. Does that make sense? If you make an A, then I'll buy you a car is logically equivalent to, if I don't buy you a car, then you must not have made an A. Those are the same things. Okay, maybe. So let me see. What do I want to do from there? I want to make you guys. Yeah, I could do that. Yeah, okay, let's do this. This is what's called, oh, you're going to love it. Here comes some definitions. This is what's called the contrapositive. It's just the technical name for negating and flipping. If I negate and flip, I get the contrapositive. Interesting, Jeff. Not really, but we'll go with it, Jeff. All right. So I'm going to take this away.
So here's a curiosity question.
Yes.
If doing a contrapositive, do we have to include positive P and positive Q in the chart? Or could we just do it with, I don't know if positive P and positive Q is the right term.
I know what you mean. Yes.
Could we just do the chart with the negatives there?
You would have to have these in exactly this order, which is based on this order. Does that make sense?
Okay. I think,
So
yeah.
you could, if you get really comfortable with this, you could forego these as long as the players you end up with are in the order that these would put them in, because that's the only way I can effectively compare to see if two things are equivalent. Does that make sense? So it isn't some arbitrary thing we decided, do it this way. No, it's because that's the only way I can compare. If they can be any order they want to be in, then how in the world could I tell if two things are the same? If they're all over the damn place, right? Maybe.
Okay, I think I follow.
I like it. This one is called the converse is just if I turn it around. So this would say, if I buy you a car, then you made an A, right? Is that necessarily true? This is interesting now. Is that equivalent to our original?
No.
No, because if you don't make an A, then I can do whatever the hell I want to. So if I make a truth table for this, should it be the same as that? No. So do it. I'll wait. Be really, really careful. P's and Q's have to be in that order. I could just teach like this. So again, one way you can do this, if you're not very comfortable, you have to start with this. But like Ian said, the more comfortable you are with this, and what it leads to. Now, I would just look this way. Do you guys, I don't know if you guys understand what I'm saying. Because Q implies P, Q implies P, Q implies P. Or if you need to, you can just rewrite them in the correct order. I have no idea. Tell me if you have any idea what I'm doing. You don't have to do this, but if you like the idea of keeping the first one first and the second one second, you first write how they have to be, and then you can put them however you need them. And now you can just look across, 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 across. Where's the only false going to be now?
Third row?
Yeah, third row is true implies false. I love it. And all the other ones are true. Is that equivalent to the earlier two statements? Is that equivalent to that?
Yes.
True, false, true, 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 false, true. Are they equivalent?
No.
No, there you go. So for two statements to be logically equivalent, the column of answers must be exactly the same. And that, again, that is the whole reason why these have to be in this order, or else how can I compare them? Okay. All right, I like it. And I don't know, I might be the only one. That's okay. All right. Let's see. Oh, and then there's one more. I'm not going to make you do the truth table for this, but can you see why this is not logically equivalent? What is this? Is the inverse. I haven't done that one yet. Yeah. This will not be logically equivalent to this, because if you don't make an A, then I won't buy you a car. Is that necessarily the case? If you don't make an A, then I won't buy you a car. No, right? That's like we said. If you make an A, then I'll buy you a car. If you don't make an A, then I can do whatever the hell I want to. So that is not logically equivalent to this. Oh shit. So here's how we summarize what we just discovered. Here we go. If P then Q is logically equivalent to, not Q implies not P. Oh shit. Okay. All right. So that's kind of like, the logic equals. Because this means that and this means that. The double-sided kind of double thing arrow. So that's logically equivalent. All right. So one or two statements logically equivalent when they have the exact same answer column. Okay, I like it. Hey, Mikey. Okay. Do. Now, let's take a look. Let's take a look real quick at some of the homework, just so you see what's going to happen to you in the homework. Let me see what I can do here. All right, let me see. Where is the book? Where are you, book? There you are. Okay. Oh, where's the homework? 23, I think, maybe. Yes. So they're going to give you some. They always have this section right here. Does it make sense? I kind of like that section, but then they've got determining whether these are propositions. So yesterday we defined a proposition. What is the main thing about a proposition? It must be a statement that can be
true or false.
True or false. It's crazy, right? Write the negation. I told you that was going to happen, right? They want you to write the negation of those statements. blah, blah. And then, of course, they talk about multiple negations, which is always exciting. I didn't not say that I wasn't going to do that. Holy shit. Are you a lawyer? What the hell is that? Make truth table. Holy shit. Make a truth table. Let's see. Blah, 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 blah. Oh, remember the inclusive versus exclusive or? Right? We talked about that yesterday. So for example, before the entree, you have a choice of soup or salad, right? Not super salad, super salad. So would that be inclusive or exclusive or?
X.
Yes, exclusive. Now, some of you guys might say, oh, I could pay some more money and get them to bring me a damn both of them. But technically, that's exclusive or, meaning it truly is one or the other. You can't have both. Inclusive or means it could be both, right? All right, let me see. And then there's more truth tables to make. There will be some statements that you might have to look up to be sure about. To determine if they're true or false, right? Okay, so nothing, I don't think there's anything too insane in this section. And be really careful. I think this is the section where I say E50, every fifth one. I have some poor people that say, man, that was a lot of homework you gave, and they did every damn problem. Like, that's not the homework I gave. So you could do more practice if you want to.
I think you explained that in the syllabus.
I totally did, but
Yes, every third one, every fifth one.
it takes about 3 or 4 times for me to say something before almost everybody hears me. So we'll see what happens. All right, let me see. Blah, 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 blah. Okay, good. So that's the homework for that section. It shouldn't be too horrible. We're going to get right into the next section, section 1C. I think we're going to talk a little bit from 1C. We'll take a break, and then we'll have some group work to do. Yay, Jeff. Okay. So let me just throw this at you. What do you think of when I say the word set? Oh shit! Can you see me? I can't see me. Hold on. There I am. Bum, bum, bum. Anybody? When I say the word set,
Pieces that go together.
I like it. Things that are related to
Like a group of things that consists of different things, pieces, items.
Good. And they're related somehow. I like that. I was waiting to see if anybody said something about tennis, but no, we're not going to talk about game, set, match. No. So a very simple set. Let me say this. How about let's start off with just pure math shit. You ready? That's crazy. Like this is a math class. Does somebody know what the set of natural numbers is?
One, two, three, 4, 5, isn't that?
Yes, good. 1, 2, 3, forever. So these are the symbols for a set. I know everybody should pretty much know this, the little squiggly symbols, right? Sometimes they come out good for me, and sometimes they're a little, had a rough night, that last set bracket. Oh, too bad for him. How about whole numbers?
Include 0 and then the rest of those.
Kind of makes sense that the whole numbers includes the number that looks like a whole. 0, 1, 2. Do you guys understand? Do you guys know, for example, that the Babylonians had no concept, had no symbol for 0? Did anybody know that? Until basically right before the civilization collapsed. Somebody's like, hey, let's use this symbol. Oh shit, we're all dead. Damn it. It's roughly the right history. You can look that up if you want to. But we don't even think about that. We're like, of course 0 is a thing, but they didn't have a symbol for 0 because it hadn't been invented yet, right? That's so freaky. What about integers?
Positive and negative numbers.
Positive and negative.
Whole numbers.
Whole numbers. I love it. -3, -2, -1, 0, 1, 2, blah, blah, blah. And then you get rationals and reals and all that kind of shit. Anybody ever heard of complex numbers? They include these horribly termed imaginary numbers.
I did last night when I was reading the book.
Dude, I like it. So real quick word about imaginary numbers. And every time I discuss imaginary numbers, students are like, I knew it. I knew it. They make this shit up. Every day I'm making shit up. You guys don't even know it. No. When people first came up with the idea of negative, many people said, what the shit is that? How could you have negative apples? If I got 2 apples and you take 3 apples, what the hell's a negative apple? Is that like a little apple black hole? I don't know. So they thought, they actually called them imaginary numbers, but eventually they realized they're useful. We need them, right? Then the same thing happened with these guys. Anybody know what these guys are based on? These are based on the idea of what this is. Right, and that's not a real number. Anyway, it's too bad I can't give you the full lecture about this because I love this shit. And I'm gonna give you a tiny taste because I can't stop. Here we go. This is nothing you have to worry about. If you want to zone out for like a minute, you can. Go with me for a second. What is 1 times negative 1? What is 1 times negative 1?
Negative 1.
Negative 1. So I rotate 180 degrees. So 1 times a half of negative 1, you could do it, Jeff. 1 times a half of negative 1 must be rotating halfway. You guys are like, oh God. No, because watch. So this is a halfway rotation. What do I get if I multiply that by another halfway rotation? What's the square root of negative 1 times the square root of negative 1? It would be negative 1. That's enough. Sorry, that's more than you needed to know. But that's why these, and all right, I'll stop. If I keep going, I'm going to just go. And we don't have to know imaginary numbers. That's fine. Okay. Another way to represent this, I've got integers. And then inside of there, I have whole numbers. And then inside of there, I have natural numbers. You guys with me on this? Does this make sense? Every natural number is a whole number. But is every whole number a natural number? No, there's stuff outside of here that's still inside there. Every whole number is an integer. But not every integer is a whole number, of course, right? And then, of course, you can put on top of this rationals, all the fraction stuff, right? And then real numbers. And then imaginary numbers will be over here. And then complex would be around the whole damn thing. That's enough. Okay, Jeff. I always go a little too far. I'm sorry. Sets don't have to be mathematical. So I could have, for example, the set of days in a week. You can do it, Jeff. There you go. So that would be Sunday, Monday, blah, blah, blah. Right. So they can certainly be. So basically, like Nancy said earlier, it's just a collection of things that are related somehow. There's a definition of things that go into the set. So they don't have to be mathematical at all. This, any piece of a set, these are called elements of the set. The book calls them members, which is fine, but the more general term is elements of a set. So Sunday is an element of the set of days in a week. 0 is not an element of the set of natural numbers, and so forth. Okay, I like it. So what I've created here is interesting. It seems to still capture the idea of a set, but it gives a broader relationship between sets. So this is actually a very weird looking example of a certain type of thing. Anybody know what this is an example of? If I tell you what letter it starts with, you probably will get it. It starts with the letter V.
Yeah,
Anybody?
Venn diagrams.
Venn diagram. I love it. Oh, you guys want to take a break now? What time is it? Let me do. Let's see. What makes more sense, Jeff? Yeah, let's take a break now. Let's take like a. What do you want? 10-minute break? Let's do a 10-minute break. Yeah, let's do a 10-minute break. You're all like, dude, you're the teacher. Just tell us what the shit. So come back at 10. And if you have any questions right now, let me know. Let me pause this.
Yeah.
You know, I hope I'm not asking too many questions. I don't want to
No.
be taking everybody else's time. If I'm like needing more time and all that, I can always ask questions after. I just don't want
Oh,
to
yeah.
take everybody's time. You know,
That's,
every time I stop to ask a question, just let me know. Because I
That's
don't
the
see
biggest part
everybody
of my
else.
job, Nancy, is to manage the course. So if you are asking too many, then I would just ask you to
Okay.
give me after class or something. So you're fine.
Yeah, sure. I don't want to, hold it to class.
Yeah, you can't do that because I'm in control. So don't worry.
Okay. Okay. Thank you.
Let me see. Okay. So what we're about to get into, where we left off, is getting directly into these Venn diagrams. And there actually was a dude, I think his name was John Venn, who created these things. He did a lot of other things, but this is the main thing he's known for, is these Venn diagrams. So what the shit are Venn diagrams? I don't know. Let's take a look. So if I put something up here, can you guys see that all right? My writing is so beautiful, but I just want to make sure. So here's the set of all men in the universe. Here's the set of all Republicans. Who would be in here?
Men Republicans,
So male
males who are Republicans.
repubs. Male repubs. Right? So who is this person here?
Republicans. Just
This person right here, who are they?
Women
Female
Republicans.
and non-binary Republican.
Exactly, thank you. Non-male repubs. All right, so people that don't identify as male, but they are Republican. Are you guys with me? I like it. I like it. Who is this person here?
Duh.
who's
Female Democrat.
somebody who's not a man or a Republican.
Yeah, so non-male. Let's do this. These are humans. I like the dogs thing. That's good. Non-male, not Republican. Why wouldn't you just put Democrat here?
Because you don't know what they are.
Exact. How many political parties do you guys know of?
4.
Neat. That's more than most. Right? Most people know Democrat, Republican, Independent. What's the fourth one you know? Just to put you on the spot.
Well, there's the Independent Party. There's also the Green Party.
There
I
you
guess
go.
I'm more-
Green.
Yeah.
There's actually a third one that's bigger than some of the other ones. Just libertarian.
Libertarian.
There you go. There's also Whigs. There's a Communist Party. There's a Socialist Party. There's, dude, you have to understand, there are 50 some odd parties that if I really needed to, I might be able to come up with some of them, but the 50 some odd parties that I've seen. Every presidential election, there are more than 100 candidates for president. Do you know them all? No. No, you don't. You only know the big ones, the ones that get enough votes and get enough stuff to get onto the ballot, but there's more than that. Anyway, sorry, that's all on this side. Sorry. I like. How would you, so this would be like an and situation, right? This is men and Republicans would go here. I like it. All right, just to point that out real quick. So that's where the and would be. So this is obviously something that is not numerical at all. These are ideas, right? So let's do one more idea. So a Venn diagram. The box represents our universe, right? Whatever. So in this case, humans, right? And then everything inside the box is put into groups, and the outside of the circles is its own group. Okay, maybe. So let me create one here. Does this make sense?
No,
Why does this not make sense?
backwards.
Exactly. It's backwards. This would be a whale that's not a mammal. That is neat. And of course, where are humans? If humans are here, then all humans are whales. That's neat. Can you help us?
I can kind of identify like right now after the holidays and everything.
Yeah. After during the pandemic, we're all slowly approaching this. I understand. All right. So the correct way to represent the idea, what idea is trying to be represented here? All
Mammals.
no. Well, what ideas try to be represented here, and they didn't quite get it right. All
All
whales
whales are mammals.
are mammals. You can do it, Jeff. So if I have all A's are B's, what would be in here, and what would this be? What would be the little circle? Yeah. What would be the little circle?
A.
Good. All A's are B's. I love it. Kind of makes sense. All of these are in these. Bam. I like it. So let's do this. I don't want to get too far down this road before we kind of work with these more specifically. So let's do this. Let me give you an interesting example. I have one created already. Look at me getting stuff ready ahead of time sometimes. Let's do this together. So I survey 360 teachers, and I find 162 of them drink rum, and 120 drink whiskey, and 48 drink both. All right. Right, because teachers, we got to find a way through. So let me make my little, what's my universe in this case? What's this box represent?
Everybody,
Not everybody.
teachers.
Teachers. I love it.
360 teachers.
Exactly. So it's good. My next question was going to be how many people are in this box? 360 of them. I like it. So what are my circles going to be?
Rum and whiskey.
Rum drinker, whiskey drinker. I like it. Drink your whiskey, drink your vodka. Sing the songs that no? Okay. No. So are these circles going to overlap?
Yes,
Why?
because 48 of the teachers drink both.
I like it. So I've got a rum, yummy, and I got a whiskey. I don't do straight whiskey. Oh well. And then I got, of course, both. Which number definitely goes there? This is where things get a little bit tricky. Don't write this. This is wrong. That is incorrect so far. It's not done either because I haven't put a number out here. But why is that wrong so far?
Because is it? I don't know if this is correct, but is it because like 162 and 120 aren't going to be 48?
I think I know what you mean. How many total whiskey drinkers are in this picture?
120.
No.
Oh, you're doubling, you're adding extra, yeah.
There's 168 whiskey. There's supposed to only be 120.
Oh, okay.
Do you guys get the idea?
Yeah.
Yeah.
So what do you do then? What do you do? This is kind of nifty. It's the same thing you do with an algebraic expression that you have to simplify. And you're all like, why do you have to bring algebra into it, math boy? Don't you start on the inside, right? Don't you always start on the inside and work out? You start in the parentheses, right? So I know 48 for sure goes here. There's no question. Okay, now, so how many drink whiskey alone then?
So do you subtract the 120
Good.
from 48?
I like
Or
it.
48 from the 120?
160, 70. 120 minus 48.
Yes.
2, 192, 182.
No, you got to subtract.
Yeah. I'm trying to do it in my head and it doesn't work very well. This
That's right. The way I do it.
72,
right?
72.
Right. So 48 takes 2 to get to 50. And then from 50 to 120 is another 70. 72. Done. All right. That's a quick way to do it in your head. What about, what good number goes here then?
114.
114. I like it because there's 162 rum minus the 48 who drink both. Now, what number goes out here? Real quick. Is anybody not understanding something so far? Somebody unmuted, but they're not saying anything. Everybody good?
Oh, I was just going to say the number 360 should go out here, shouldn't it?
No, be careful, not 360. No,
Oh.
because who would this person be right there?
Oh, okay. The total of all these people, drinkers.
Yeah, so how many total people do I have down here so far?
178, something
No,
around there.
234.
that might be right. Yes, 234. I got 114 here, plus 48 there, plus 72 there. I really want you guys. Who are these people right here? Who are these 114 people? What do they do?
They drink rum,
But not
whiskey.
good. These 48 drink both.
Uh-huh.
And these 72 people drink,
Whiskey, not rum.
but not rum. I love it. So how many people do I have so far? 114 plus 48 plus 72. And I've already forgotten what it was. 234.
Yes, but we're still missing 126 of the 360 total.
So what goes out here? What you just said, right?
Oh, 126?
There you go.
Oh,
Because who is this person? Who is this person here? Who are these 126 people there? Let me just say it like that.
non-drinkers,
Careful.
people.
People that don't drink rum or whiskey.
Yes,
Could they
there
still
we go.
drink? Yes. Vodka, moonshine, lemon chia, grappa. Be careful, kids. I ate a piece of peach that had been in moonshine for several years, and I think I still feel the effects of that.
Oh my goodness.
That was like, I needed to sit down for the rest of the night after that. Well, it was a great party until I had that piece of peach, and then I was like, I'm done. Okay, I like it. You guys semi okay with that? That's a little tricky, isn't it? More tricky than you would think, but doesn't make sense, the trickiness, the thing you got to be careful about. Okay, I like it. You're not going to have to create, I can't remember now in the homework if you even have to do this at all, but I wanted to show you how these are constructed, because then when I do what I'm about to do to you right now, which is give you one that's already constructed and ask you questions, it should be a little easier. So if you are able to access Canvas right now, please do so. I have added something new. I kind of made this first. Let me change the title of this. I added two things. I added the video about complex numbers. You don't have to watch it if you don't want to, right? Where else? And then right down here in unit 1, I added this Venn diagram practice. So that's what we're about to do right now. Is anybody not able to access Canvas right now? So everybody can, okay. So please go to Canvas. If you want to print this out, if you have a printer, feel free. I want you guys to kind of start working on this. There's 2 sides to this, right? Now I'm going to definitely order some pizza for lunch later because I have to, because I made this problem. And then this one's about number of calories. So it's going to make me feel ashamed, but I'm still going to order pizza. I don't care. So I want everybody to try to start working on this individually, and then I'm going to create breakout rooms, and you're going to kind of check answers with each other. Yes, everybody understand what's happening? All right, let me know if you have any questions. Otherwise, go ahead and access Canvas, get a hold of that bad boy, and start working on it.
Excuse me, Professor, where's it at again?
Oh, yeah, so let me show you. So you come in, you go to modules. Anytime I have a handout or something, it's going to be in modules and then under the correct chapter. So chapter 1, unit 1, yeah.
Great. There we go. Thank you.
Sweet. All right, I'm going to stop recording for a bit while you guys work on that. Oops, shit. Good thing you're here. So everything since the break was not recorded.
Oh my gosh, that's not good.
You gotta, I'm sorry. You gotta help me out with that. I'll do that. I just get so into it, I forget what the hell's going on. So let me make sure. Let's see what you guys are doing. So premise 1, all states east of the Mississippi are small states. So what are your 2 circles? Let me open this up over here. Sorry. Hold on. So I can draw on it. Anybody? Anybody? I'm not asking what they look like, just asking what are the circles?
Small states and states east of the Mississippi.
Yeah, there you go. Now you got to worry about, so I want small states and I want states east of the Mississippi. So all of these are these. So what's it going to look like? Is it going to look like this? No. Is it going to look like this? No. It's got to look like this bad boy, right? You guys with me? Anytime you have an all premise, it's going to be one of these, the circle's completely in that other circle. What's the small circle going to be? Might have made that a little too.
Small states?
Be careful. Iowa doesn't come into play yet, right? We're just doing the first premise. We have to do one premise at a time. I'm sorry, I don't know what you said, Nancy, but somebody said Iowa. That's not, we're not there yet.
I said small states. Oh, never mind, never mind. I said that a while ago.
Let me see, hold on. Let me erase this so I can make it a little bigger. So what's cool about this is you can take a guess. So if I say the small circle is small states, and the big circle is east of the Mississippi, does that capture what this says? Is every state east of the Mississippi small? Is that state east of the Mississippi small? No, so this is just backwards. Nothing wrong with trying it and seeing you made a mistake. Just go back and change it. Let's see if I can do this. Oh, scheisse. All right, let me redraw it. You guys with me out there? The big thing about making mistakes is it's part of the process, right? In fact, there's whole classes of mathematics where you have to make a mistake in order to tell which direction is the wrong way to go. So it's a part of the process. So now I know what goes in the small circle.
East
States
states.
east of the Mississippi.
Good. East of the Mississippi, and this will be small states. Iowa is a small state. So where could Iowa go? Does it have to be in the East circle? Does it have to be?
No.
Could it be? Yes.
No,
Does
wait.
it have to be?
Do
No.
we need a new circle?
No. Iowa is a single element. I really want you to understand. Circles here represent states. Isn't Iowa just one state? So what did I do anytime I said like me with the olives? Remember, I was just a little X.
Yes.
So where could I put Iowa here? Yes. Does it have to be there? Could it be here? Yeah, it could be here. So is it necessarily true that Iowa is east of the Mississippi River? Does it have to be true?
No.
No. So these premises do not necessarily lead to this conclusion. So is this a valid argument?
No.
No. The premises do not necessarily lead to the conclusion that was made. Now, each of these problems are kind of silly in a sense, right? Not many, you're not going to like see this argument somewhere, but can you understand how you could come to a conclusion in an interview, on a news program, giving a speech, using premises, come to a conclusion that sounds good, but actually if you analyze it, it's not valid? Do you understand what I'm saying? I mean, that's the part I want you to realize is don't focus too much on the specific problems you're doing. Realize that these kind of issues show up all the damn time in speeches, in interviews, in articles, in whatever, on Facebook for damn sure, hello, or whatever the hell you guys got. Your TikToks and your Musical.ly, is that even a thing anymore? I don't even know. No idea. All right. This is what I thought was happening. This is what I tried to start to do in the last section. I don't know if you guys remember, but this is the where Venn diagrams kind of intersect with analyzing arguments. Okay, maybe. So you take the premise. The premises have to be represented with a Venn diagram, and then you step back to see if they necessarily reach the conclusion. Bless you. Let me see. I feel like there was something else I left out. Any questions on that problem we just did, number 31?
Yeah, so where's Iowa?
Oh, Iowa could be here, or it could be here. So I want you to realize that's the key.
It could be an either, right? With an X?
That's right. That's right. So is the conclusion the only conclusion you can make with these premises? No. That's why this is not a valid argument. The conclusion does not necessarily follow. Does that make sense?
So if we were to encounter I don't know if this is on the homework or not, but if we were to encounter a question like this in the homework or the test or whatever, the answer we would be looking for or trying to do would be putting both X's, not just one.
Yeah, exactly. You need to make sure, especially if you think the conclusion is correct, you need to stop and say, could I have drawn this a different way? And the premises are still represented, right? So both of these places for X represent these premises, correct? But only one of them leads me to this conclusion. So is this argument valid? No, because the premises don't necessarily lead to the conclusion. I love you guys. This is weird as shit, right? Anytime you mix math with English, not everybody's going to have a good time. I have a good time. I have a great time. I love this shit, but I'm weird. Let's see. So try number, I'm sorry, go ahead.
If the the argument is invalid if the premise doesn't lead to the conclusion.
Yes, if the premises do not necessarily lead to the conclusion, it's invalid. So notice how that didn't say a damn thing about anything being true or not, right? In fact, this number 31 specifically has a very strange element that's not even about truth. What do they consider to be small, right? That's subjective. They don't define that, but that's an extra thing, right? So an argument being valid or invalid says nothing about the truth of any piece of it. Are you guys with me? So the invalid valid piece is just, does your argument follow? Does your argument have good structure? Then you say, are the premises all true, right? If the premises were all true, it would be what's called a sound argument. Okay. Crazy shit. All right. Try number 34 real quick. And then we'll do an if-then problem. So let's see, I think we've done enough of these all ones that you know the first premise is going to have to look like this. What goes in the little circle?
Vegetables?
Good.
Oh, okay.
Don't be surprised when you get it right. Be surprised when you get it wrong. So all vegetables are green. If you drew it the other way, then this vegetable is not green. Do you see? I mean, that you can very quickly tell if you have it wrong. So all vegetables are green. Beans are green. Therefore, beans are vegetables. Some of you guys might realize that the structure. Sorry, say it.
Is it a double X?
Yeah. Where could X be? Could X be in here and then the conclusion is true? Yes. Does X have to be in there? Do the beans have to be there? They could be out here, right? So again, you got to let go of, we know beans are vegetables, but does that mean that this argument is valid? No. So the most frustrating thing is to have a true conclusion, but somebody can throw your argument out because it isn't valid. Oh, shit. I don't know if anybody's ever done any debate or anything. That sucks so bad when you know your conclusion is right, but your argument is not valid.
Can you go over number 34 one more time, please?
Yeah, sure.
Sum it up.
So are you cool with the first step? All vegetables are green. So vegetables have to live inside the green circle, right? Beans are green. So where would beans go? They just have to be in the green circle. So they could be here. They could be there, right? I mean, they could be over here. They could be over there. I mean, but basically it's either they could be here or there. So is it necessarily true that beans are vegetables from what we know in this problem? Do they have to be vegetables? No, they could be right there, right?
So they could go
They-
anywhere. They could go on in the little circle or in the big circle, correct?
They just have to be in the green circle,
Okay.
right?
Okay.
Which doesn't mean they have to be in the vegetable. So what would happen if I switched these two? If I switched these two right here. If my second premise was beans
Then the
are
beans
vegetables.
With the vegetables,
Say again, sorry.
then would it be the beans had to go in with the vegetables if you switched? it?
Good. If I said the second premise was beans are vegetables, they would have to go in the vegetables. And then is it necessarily true that they're green? Yes, because they're also in the green. I just made a circle. I'm sorry. Let me erase that. I'm trying to make a point. Yeah.
And we would do it like that, put a G there
Yes.
to represent beans are green.
Well, this represents green.
Green.
This
Okay.
This here represents green. This here represents vegetables, and this here represents beans. The little X.
Where? I'm sorry.
Can I
Okay.
ask a question?
Yes.
Okay, so essentially you're saying that the conclusion is false because it fits
Careful.
into both categories?
I didn't say the conclusion is false. I didn't say anything
It's
about
not
false.
valid.
There you go.
The conclusion is not valid because it fits into both and not just the
Yes.
one.
The argument is invalid because the conclusion does not necessarily follow from the premises. Given these two things, can I say beans are vegetables? No, because they could be right there. They just have to, with what I know, they just have to be green. Now, I really want you guys, I almost know there's somebody out there saying, what about kidney beans? They're not green. All right, stop. We're not talking about the truth of anything here. It's just like you know nothing. And then they say this, like that's the only thing you know in the whole universe. And then they say this, like, now I know two things. And then you say, does that mean I know this? No, I don't know this because it doesn't have to be in the vegetable circle. Go ahead, sir.
It's not based off of what we know. It's only directly what is in the book.
Exactly. Exactly. So these premises are your entire universe. And then you say to yourself, can I say this for sure? In the two examples we just did, 31 and 34, I cannot say this for sure. So it's not a valid argument. It sounds difficult. It isn't. And it could be just, I can't explain it very well, but that's really all it is. It has nothing to do with the truth. So if I have an argument that is valid, does that mean that I'm right? My conclusion. If I have an argument that is valid, does that mean my conclusion is true? You can do it.
No.
No,
No, it does
you might not have a good argument.
No. My argument is valid.
Oh,
Does that mean my conclusion is true?
well, it depends on your premises.
What exactly about them?
If they're true.
Beautiful.
They're
There you go. So the idea of valid or invalid has not a damn thing to do with the truth of any of the parts.
So all vegetables are green is what makes this not valid, right?
In a weird way, maybe. But it's the
It's not
fact,
true.
to be honest, what did we just say? What was the way I could save this? Didn't we say if I switched the second premise and the conclusion, doesn't it become valid? Do you see that? If I switch these two, that makes it valid. Why?
Vegetables are green, beans are vegetables, beans are green. Oh yeah, okay, because you're switching, yeah.
Yeah. So if I switch those two, if beans are vegetables, they have to be here. And then I can say beans are green. Yeah, I know that because if they have to be here, they have to be in this guy. Okay, maybe. So that's why I'm saying, and that's not the only way to fix this, right? There might be other ways to fix this, but that's the most immediate way. Does that mean that the conclusion is true? No, that's a separate process. Okay. All right. And I know this is really frustrating for people, but you cannot This has to happen for yourself also, but this is really trying to prove something for somebody else, but it's also how you prove something for yourself, right? You can't, so nowadays there's a lot of, I just know it in my gut. And man, humans have proven that gut feelings are very, very often, not always, they're very often incorrect, right? So we need something outside of ourselves, some method to analyze things. All right. Let's do an if then, and then I think we'll call it a day. We'll be a little bit earlier than yesterday, just so we don't all go crazy too soon. Maybe in the third week, we'll all go crazy. Let's see. What about number 43? Let's do that one together. Let's see. If a tree is deciduous, it sounds like it's evil or something. If a tree is deciduous, then it loses its leaves in the winter. Okay, so what do I have so far? That's my universe is made up of that sentence. So how does my universe look? Does anyone remember? It's actually on the board behind me, I think, right? You can see it. So if a tree is deciduous, then it loses its leaves in the winter. Is that cool? You guys see that? So try it. If a tree is deciduous, there it is. Does that tree lose its leaves in the winter?
Sure.
Because it's in this circle. I like it. All right. Fir trees do not lose their leaves in the winter. So where do I make the circle for fir trees? Or where do fir trees go? Not even a circle, it's just a little dot. Where's he go? Fir trees do not lose their leaves. So he cannot be in where?
In the middle circle. Middle circle.
He can't be in the big circle. He's got to be outside the big circle, right? Is everybody with me? Or is anybody not with me? I've got to ask it like that.
What is the small d in the small circle or the d in the small
All right.
circle?
Deciduous. I just didn't want to.
It's because I was writing. Thanks.
Sure. That's not very good, Jeff. Deciduous. And then this is fir trees. The only thing we know about fir trees is they don't lose their leaves. So they can't be in the circle that represents things that lose their leaves, right? Conclusion, fir trees are not deciduous. Is this a valid argument?
Yes.
Yes, because here's my fir trees. Let me put a little F for fir trees. Right? Could they possibly be deciduous? No. So therefore, this is our first example of a valid, yay. To be really honest, I have no idea if those are right. I don't know. Are there fir trees does every fir tree not lose the leaves? Deciduous? Does somebody know if that actually, I know that word, but man, I feel like that's what it means. I don't know. I have to look it up. So the next level would be if the premises are all true, then this is a sound argument. The conclusion must then be true. If this argument was invalid, what can I say about the conclusion?
Not true.
Nope. The correct answer is nothing. Can't say anything. I really want that to get through. If an argument is valid that doesn't say anything about the truth, I really want you guys to understand. I thought we were there, but maybe not. Okay. To be valid means the structure is good. That doesn't say a damn thing about the truth, the veracity of the statements, right? Oh, what's going on here? Italian people speak Italian. James Bond is Italian. James Bond speaks Italian. Oh yeah, there you go. It's valid, but not true because not all Italian people speak Italian. Exactly. Thank you. All right, that's a nice example. Now I want freaking spaghetti. All right. All right, I think that might be enough for today. We basically finished chapter 1. We do 1A through D. I think that's enough for today. So let me know if you need to hang out afterwards, ask some questions. Could be about what we talked about, or it could be technical issues or whatever. Let me know. Otherwise, you are free. I'm sorry. Why is it valid but not true? Oh, the James Bond example, Lexi?
Yeah.
Because are all the premises true? For example, is James Bond Italian?
Yes.
I like it. All right. Well, maybe Google.
Sorry.
Maybe Google.
I don't know.
But how about does every Italian person speak Italian? No.
No, because you have a bunch of Italians that are just a little bit Italian, and some that are, raised in America or here in North America, and they don't know what Italian.
So that's the key. Do you guys see? This is valid though, isn't it? Now you left out the word all, but I'm with you. If all Italian people spoke Italian and James Bond is Italian, then James Bond would speak Italian. That argument is valid. Because if you drew the pictures, it would lead to that conclusion. Are the premises true? No. So that is not a sound. It's a valid argument that isn't sound or isn't true. The conclusion is not necessarily true because the premises are false. Could James Bond speak Italian? Yes, of course. He could have just taken an Italian course. I don't know who James Bond is currently. Is it still Daniel Craig? I don't know. So the character James Bond could speak Italian. We don't know. The argument doesn't lead to that conclusion because the premises are not true. Oh boy, that's a lot of shit to go in your brain at the end of the class. I'm sorry, but we'll do some more examples first thing tomorrow. Anybody else have questions? Or are you just kind of like waiting?
No,
Ahead,
I have
sorry.
a question. Yeah. If we turn the homework in early or just kind of a couple problems to see if we're on the right track, could we get feedback before it's finally graded, or once we turn it in, it's turned in for grading?
I will give you feedback no matter what. And then, I'll tell you if you need to finish it or correct it. Does that make sense?
Mm-hmm.
So
Okay,
you could
thank
get
you.
back at the full credit if you don't quite get everything right. So that's pretty much what you're always doing. You do it, you turn it in, and you go, let's find out how, let's see.
Okay.
And I'll tell you if you got too many wrong or something that you have to correct it. Yeah.
Okay, thank you.
You're welcome.
Thank you, Professor. Have a good day.
You too. I think everybody just wants to not miss a question. Go ahead, Ian.
You dismissed class, didn't you?
What happened?
You said class is dismissed, question mark?
Yes.
Oh, okay. I wanted to make sure I wasn't leaving early.
Yeah.
See you tomorrow.
Okay, see you. I'm going to assume everybody else is good.
I actually had a quick question
Right,
about the homework 1B. I kind of had a breakthrough about the P and Q thing, but now that I'm looking at the homework, I don't know, it's a little shaky again. And I just want to get some clarification on number 35 and number 40, because they're same, so it's a little tricky.
All right, hold on, let me see. This one here. All birds can fly and some fish live in trees. Okay, right?
Yeah, it says it wants us to state the P and Q.
Yes. So what's P?
Birds?
Well, no, what P is all birds can fly. So P and Q are variables that represent statements, right?
Okay.
So they represent the parts of it. So P is all birds can fly.
Uh-huh.
So what's Q?
Some fish live in trees.
Good.
And then
And then you just tell me, is P true or false? Is Q true or false? And then you tell me whether the whole statement, the and in this case, is that true or false?
okay, I'm getting that mixed up. Yeah, I see. I'm thinking I'm supposed to do like a truth chart for those ones.
Oh,
but
no,
I
you
guess
don't
I'm
have to.
completely wrong.
The reason you don't have to do a truth table for this is because you know the truth value for both P and Q. You don't have to capture all the possibilities because you know not all birds can fly. Poor little penguins, right?
Yeah.
And I don't know. I'm pretty sure no fish live in trees, but you never know. I'd have to Google that to be really sure. But I'm pretty sure no fish live in trees, but that would be interesting. They kind of need water, but I won't. That's why you don't have to make a whole truth table.
Okay, I see. Thank you for that. And another quick one, just on like say number 30, for instance, it's P and S. And when we were doing when you were doing examples, we were using the P and Q. So when we're talking about the letters P, Q, R, and S, I guess I'm kind of
the only time you have to worry. So they're always in alphabetical order. And this one's a little bit silly. It's going to have the exact same values. So you put P, you put S, true, 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 false, false, true, false, false.
Every single time, every time it asks me for P and S or
2 letters. If you have 2 letters, it will always be that because that captures all the possibilities. You put them in alphabetical order, and then you write those true, 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 false, false, true, false, false. Yeah. There's nothing special about S. It's sort of like X and Y. Nothing special about those letters. Yeah. They just normally are in alphabetical order, right?
Well, if I'm understanding that correctly, or I don't know if I'm misinterpreting it, wouldn't they just all be the same then? Like if you did a truth table for Q and R and then P and S, wouldn't they just both be the same?
That's right. They're the exact same.
Oh, okay. All right. I guess I'm just kind of overthinking a lot of stuff.
Yeah, I'm not sure. I think they just want you used to the fact that those are the 4 main variables. But there's really no point to replace Q with S. But that's all they did in number 30, right? They just replaced Q with S.
Yeah.
And you're like, all right, whatever the hell you want to do. It's going to look exactly the same. You're right.
Okay. All right. Thanks for the clarification. I appreciate that.
Yeah, you're welcome.
I'll see you tomorrow.
How's everybody else? All right. See you then. Is everybody else all right? Anybody?
Hey, Professor. Yeah, I just want to say something really quick. So I don't know if everybody has ordered their book or like if anybody like is having trouble getting it or anything, but there's this website called The Library that I use, and I don't know if you're allowed to like send out links and stuff, but the whole entire textbook is on there for free to download.
Ooh, wait a minute. So what's it called?
It is called, here, let me go to really quick.
The Library?
Z, the letter Z, and then a hyphen. Z? Yeah, Z, and then a hyphen, and then lib, L-I-B, .org.
I see it.
Yeah. And then you just click books, and then in the search panel, you can I just copied and pasted the book, and it popped up, and I just downloaded it. It took like 2 minutes to download, so the whole thing is there.
God, that's so cool. There will be people that will be upset that I didn't find this out sooner, but I never heard of that.
Yeah,
I have to check into
that's where I get all of my textbooks from. So if
pretty sure
anybody needs that,
this is probably legal, but
it ends in org, so I hope so.
Well, yeah. I'm pretty sure it has to be legal, but I'm going to check it out real quick and make sure.
Okay.
Because if I post something like this, oh man, I'm going to get some shit if it's not
definitely.
Really.
No, I feel you. But just throwing it out there, just in case anybody needed the book or anything.
Sure. Yeah, thank you for that. If it turns out to be legal, that kicks so much ass.
For sure.
Yeah.
All right, Professor, I'll talk to you later.
All right, see you. Let me see.
Okay, hi, Professor.
Hey, what's up?
Okay, so I have like the biggest not the biggest question. I'm just dumb, and I like still don't really understand like the like chart, like the true false chart. Like the basic one I get, but like the one we did today where it was like if P whatever is false, if like P then Q, like I just can you redo that, talk about it again?
Are you talking about, so we did so P and Q always starts off like this, right?
Right.
And then we did the if P then Q, this one. And that one was okay? Is it when we
No,
did the not? Sorry.
Okay, can we do that one and then can we do the other one?
So this one, the funny thing is this table is not work. It's actually just the definition of what this is. The only time this can be false is if the first thing is true and the second thing is false. So there's no work I did to fill this in. It's just that this is the only time it's false. So if you make an A, then I will buy you a car. If you make an A and I don't buy you a car, then what I said was false.
Okay.
And then
Okay,
everything
okay,
else
okay.
is true. So it's not, I didn't do a damn bit of work to figure this out. Now, where we did work is when we had to figure out this guy, right?
Okay,
And
wait, I
little
have a
bit of work-
question.
Yeah, good.
On the last one you just did, like the bottom row, it would be like, so what would it be? If I don't buy you a car, then you
So the
won't
thing
get
about
the
these
car.
two, if you don't make an A, which is what both of these say, right?
Yeah.
Thing is, if you make an A, then I'll buy you a car. So if you don't make an A, I can do whatever the shit I want to, and it's still true. I
Okay.
didn't lie to you. So if you don't make an A, I can get your car, or I can not get your car, and I didn't lie to you.
Okay.
The
okay,
one
okay.
time I would have lied to you with what I said is if you do what you're supposed to do and I don't.
Okay.
That's
Okay.
the one
Okay.
time.
Okay.
I talked about it like breaking the contract, right?
Okay.
This required some work because we start with PQ and then we have to make not Q and we have to make not P.
Right.
But then to do it, I still just see where is it TF, and that's the only F, and everything else is a T, right? But there was a little bit of work I had to do because I don't have the not Q and I don't have the not P to start with, right? So here's true, 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 false, false, true, false, false. So let me create my not Q. It would be false, true, right?
Right.
And my not P would
So
be false, false, true, true.
Uh-huh.
And then the if then is only false if true implies false. So that's false, and the rest of them are true.
Okay. Okay. I got it.
So that whole thing about it's only false if true implies false, that's kind of like the work, but it's not really work. You just find that one, you find where that's true, and you put an F, and then everybody else is a T. And that's
okay.
Doesn't seem like a lot of work because it isn't. Yeah.
Cute. Awesome. Thank you very much.
You're welcome.
All right. Have a good day.
You too. Order my pizza. All right.